20% of all of the marks in GCSE Science are for math skills, but do you even know what they are? Hi, I'm Dr. De Bruin. I'm a GCSE and A-level science teacher, and I also make revision videos on YouTube. Every year, a bunch of people come out of their science, and it's usually biology papers, partly because it's first and partly because everyone kind of expects the maths in physics. And they come out asking, why were there questions about standard form and percentages and significant figures? I thought I was taking a science exam, not a maths exam. And every year I'm there like, you guys know there's a list in the specification, right? Higher tier science, then the math skills have to be at least a GCSE foundation. So that includes using standard form, ratios, fractions and percentages, making estimates of simple calculation, rounding to an appropriate number of significant figures. Pro tip, appropriate means the same number that they've used in the question. Calculating and using frequency tables, bar charts and histograms. Sampling, like figuring out how many daisies there are in a field. Probability, like what are the chances that a particular child is a girl and that they have a certain inherited disease. Mode and median, using a scatter graph to determine whether there's correlation between two variables. Order of magnitude calculations, using lesser than and greater than signs, and the little fish thing for directly proportional, and the tilde sign for approximately equal. Changing the subject of an equation, substituting values into an equation, solving equations, translating information between numerical and graphical form. In other words, can you take a table and draw a graph, and can you read numbers off a graph and put them in a table? Understanding that y equals mx plus c represents a linear relationship, determining the slope and the intercept of a graph, drawing tangents and using those to calculate rates, calculating the area under a curve. That one's for physics when you're trying to figure out the distance by using a VT graph. Measuring angles in degrees, so don't forget your protractor. Using 2D models to represent 3D objects. And then a bit of geometry, so calculating the area of rectangles and triangles, and then the surface area and volumes of cubes and cuboids.